Yeah, that's Bill Wells right there. Say hello, Bill. And what drive is that out there, Bill? What's that?
Hempstead Road.
That's Hempstead Road. We're standing at Reliant's property right here, and you can see the time at least.
Road and right at the building.
Right. What is that, Souden?
Yeah.
And this is the production building over here. We're on about 2 acres of land, right? And let me give you the date right here. It's October 24th, 1989. Okay. And I'm going to give you the time right here. All right. And this is the office building right here. Okay. Now that's an old building there, and it's what we use as an office building. There's our van, and over here is finished product and raw material storage. That's that building right there, finished product and raw material storage. The property line goes all the way back past that old truck, all the way back to that fence back there. Okay, and I'm panning back on this. Okay, kind of give you an idea how the property is. All right. We have a septic tank that's underneath this property right here, and we have another septic tank that's right over here.
Right by that light.
Right by that light right there, okay? Okay. This is the well water supply system with the water storage tank. What size pump do you have on that, Bill? You know?
I've forgotten.
He's forgotten. And there's Bill's car. Okay, that sign right there, it's Reliance Chemical Corporation is the name of the company. It's a Texas corporation. Okay, this is the micro lab, and we're kind of entering the micro lab as we speak here. Bill's gone outside, and it's kind of a messy laboratory, but you can see what it is. All right. There's a telephone, and you can see this. This is standard micro lab. This is a microfirm fermenter. This is about a $20,000 rig right here. We've looked into this and just haven't been able to justify or afford one of the babies. There's one of the little fermenters, and there's your pH controllers. Okay, this is your sterile room. Not very sterile at this time, but it's good possibility there. This is a real mess. It's like Tarver needs to be around here. Walking back here, we've got all kinds of wild stuff in here. And this is a clean hood, supposedly. We got a lab line incubator here, very important. And we've got an oven, and we've got Bill Wells. Now we're walking out to the plant. We got about 50 feet, no, about 30 feet heat height here. See this? This is their rotary inoculator. What you hear behind me is a boiler. And these are the tunnels over here, all the trays. This is oh baby, scare me to death. This is all the fermenters. Beautiful. Thank you, Bill. Walking down here, you can see the amount of equipment. This is all air drying equipment. system. More fermenters. This is their boiler. This is their grinder. Big sucker, huh? Back here we have the rest of the trays and the rest of the building. Looking right around, right back up front to where I came from. Okay, we're back at the submerged fermenters. Look at the electrical stuff. Control system. Okay, this is the back of the building there. And that's the water softener. Here. Well, this is the back of the property here, and Bill's clearing it off right now. This is the back 40 of about the 2.5 acres. We've got plenty of room back here. Okay, we're going to go right down this building real quick. Look at there. And here's Christensen. And who is that? Who's that motley group with Christensen? It's Tommy Martin. And hello, John.
Hi.
Say hey to the camera. And as Mr. Clark is switching on the lights right here, we're just going to walk down the inside of the building. This is basically raw material here, Phil. Get out of the way, John.
Raw material here.
All right.
I'm going to go, I'm going to let Tommy use your phone in the office. He just needs to call.
Okay, this is finished product that's being shipped. Jones Grub. This is a ribbon blender. Okay. Ribbon blender here. And we have a smaller ribbon blender here. All right. This is some dry material here. Okay. And this is all finished product down here. Okay. Okay. Don't say okay. Finished product goes the whole length, all the way down to the other end of this building. Boy, I love this camera. There's one thing down here I want to show you. That looks like some raw drum, just some drum. This is a tabletizing machine. You got two of these big old Stoker tablet making machines here, and don't know what to do with them. And that's a big top ribbon blender. And this is the building looking from this end down. Okay, and I'm going to show you the inside of the office. That'll be about it. Thanks. Okay, that's the little office there. Oh, you don't want me doing this, but okay, we're going to do the inside of this building here to show how classy the stuff is on the walls, huh? Okay, we got a little office here. The best thing we can do with this building is, and we've got Candace and Mark busily working. Good for you guys. The best thing we can do with this building is knock the sucker down. We got a little office over here. Isn't that right, Bill? The best thing we can do with this building is knock it down?
That's right.
Level this sucker.
Except we need it for storage.
Well, we need it for storage, though. And he's got, are we still selling you those bags, or are you getting those bags from us? We bought like 20,000 of those things.
Well, we bought half of it. And that's the reason we're storing these in here.
Hey, you see that little rooftop stuff right there? That's what that big old pressing machine I just showed you a minute ago presses out. And these are some of the bags here. And other than that, we're in good shape. Say bye, John. Bye. Yeah, that's Bill Wells right there. Say hello, Bill. And what drive is that out there, Bill? What's that?
Hempstead Road?
That's Hempstead Road. We're standing at Reliant's property right here, and you can see the time at least.
Road is right at the building.
Right. What is that, Soudan?
Yeah.
And this is the production building over here. We're on about 2 acres of land, right? And let me give you the date right here. It's October 24th, 1989. Okay. And I'm going to give you the time right here. All right. And this is the office building right here. Okay. Now that's an old building there, and it's what we use as an office building. There's our van, and over here is finished product and raw material storage. That's that building right there, finished product and raw material storage. The property line goes all the way back past that old truck, all the way back to that fence back there. Okay, and I'm panning back on this. Okay, kind of give you an idea how the property is. All right. We have a septic tank that's underneath this property right here, and we have another septic tank that's right over here.
Right by that light.
Right by that light. Right by that light right there, okay? Okay. This is the well water supply system with the water storage tank. What size pump do you have on that, Bill? You know?
I forgot.
He's forgotten. And there's Bill's phone. Okay, that sign right there, it's Reliance Chemical Corporation is the name of the company. It's a Texas corporation. Okay, this is the micro lab, and we're kind of entering the micro lab as we speak here. Bill's gone outside, and it's kind of a messy laboratory, but you can see what it is. All right. There's a telephone, and you can see this. This is standard micro lab. This is a microfirm fermenter. This is about a $20,000 rig right here. We've looked into this and just haven't been able to justify or afford one of the babies. There's one of the little fermenters, and there's your pH controllers. Okay, this is your sterile room. Not very sterile at this time, but it's, you know, good possibility there. This is a real mess. It's like Tarver needs to be around here. Walking back here, we've got all kinds of wild stuff in here. And this is a clean hood, supposedly. We got a lab line incubator here, very important. And we've got an oven, and we've got Bill Wells. We got about 50 feet, no, about 30 feet heat height here. See this? The rotary inoculator. What you hear behind me is a boiler. is a tunnel over here. All the trays. This is oh baby, scare me to death. This is all the fermenters. Beautiful. Thank you, Bill. Walking down here, you can see the amount of equipment. This is all air drying equipment. More fermenters. The air supply system. Fermenters. This is their boiler. This is their grinder. Big sucker, huh? Back here we have the rest of the trays and the rest of the building, looking right around, right back up front to where I came from. Okay, we're back at the submerged fermenters. Look at the electrical stuff. Control system. This is the back of the building there, and that's the water softener. Here. Well, this is the back of the property here, and Bill's clearing it off right now. This is the back 40 of about the 2.5 acres. We've got plenty of room back here. Okay, we're going to go right down this building real quick. Look at there. And here's Christensen. And who is that? Who's that motley group with Christensen? It's Tommy Martin. And hello, John.
Right.
Say hey to the camera. And as Mr. Clark is switching on the lights right here, we're just going to walk down the inside of the building. This is basically raw material here, Phil. Get out of the way, John.
Raw material here.
All right.
I'm going to go, I'm going to let Tommy use your phone in the office. He just needs to call.
Okay, this is finished product that's being shipped. Jones Grub. This is a ribbon blender. Okay. Ribbon blender here. And we have a smaller ribbon blender here. All right. This is some dry material here. Okay. And this is all finished product down here. Okay. Okay. Don't say okay. Finished product goes the whole length, all the way down to the other end of this building. Boy, I love this camera. There's one thing down here I want to show you. That looks like some raw drum, just some drum. This is a tabletizing machine. You got two of these big old Stoker tablet making machines here, and don't know what to do with them. And that's a big top ribbon blender. And this is the building looking from this end down. Okay, and I'm going to show you the inside of the office. That'll be about it. Thanks. Okay, that's the little office there. Oh, you don't want me doing this, but okay, we're going to do the inside of this building here to show how classy the stuff is on the walls, huh? Okay, we got a little office here. The best thing we can do with this building is, and we've got Candace and Mark busily working. Good for you guys. The best thing we can do with this building is knock the sucker down. We got a little office over here. Isn't that right, Bill? The best thing we can do with this building is knock it down?
That's right.
Level this sucker.
Except we need it for storage.
Well, we need it for storage, though. And he's got, are we still selling you those bags, or are you getting those bags from us? We bought like 20,000 of those things.
Well, we bought half of it. And that's the reason we're storing these in here.
Hey, you see that little pressing machine I just showed you a minute ago presses out? And these are some of the bags here. And other than that, we're in good shape. Say bye, John. Bye.
Chris?
Diluting it. Each of these large bottles is like 10 of that mix too.
the food service sales manager for InterBio, based in Baton Rouge, Louisiana. Today I have with me Eric Toro, who is the general manager for Bacteria Power in Puerto Rico. Bacteria Power is a distributor for InterBio, and actually I've just asked Eric if he would mind chatting with us a few minutes just to see, learn a little bit about his business and what makes him so successful. Eric, thank you for being here. I wanted just to ask you just a few questions. Tell me a little bit about your company, Bacteria Power, and the service that you folks provide.
Of course, Eric, first of all, thank you for giving us the opportunity to share our success in this business. Well, as you say, we are based in Ponce, Puerto Rico, in the south of the island. We have a great service business there because we have combined this biological concept into the wastewater, especially on grease trap business. The way we work down in Puerto Rico, we combine specialized product in order to reduce the amount of waste caused by the excess of oil and greases, especially found on grease traps that are commonly found on kitchens and restaurants. As a matter of fact, we handle 75% of all the fast food chains in Puerto Rico, including most of the major U.S. fast food chains found in USA. Fast food like hamburgers, chickens, all kind of restaurants.
So broad cross-section there in restaurants. What type, one of the things you and I were talking about earlier was the service that you guys provide, and I think that's really probably one of the things that separates Bacteria Power from a lot of the competition that's out there. And could you tell us just a little bit about your service, which you guys do?
That's true, Eric. We have found that in this business, you have to help the customer in order to get the result fast. So the way we handle this is we make sure that we get the right environment in our system, in this case the grease trap. So we have total control of our accounts. We don't sell product, we sell service and results. Okay, so for example, we get a new account, a restaurant. We install our system, which are the peristaltic pumps that supply the product. Okay, in our visits every other week, our technicians make sure that the equipment delivers the right amount of product at the right time. Okay. Also, we check on the drains, the sinks. We make sure all the strainers are on a good position. After that, we even go out to the restaurant and check and work with the grease traps. We treat the grease trap as a wastewater treatment plant. Okay. So we measure pH, nutrients levels. If there is an excess on waste and on oil, we take that excess in order to give a better environment to our product. But one important thing in this business is that you need to have the right biological product. On the market, there are a lot of small companies that sell household products that they're not specially designed to work in this specialized market.
Do you use a liquid product or a dry or a little of both?
Okay.
How does that work?
We use both because we want to make sure we get a excellent result. So on a daily basis, we use our liquid product, which is injected by dosage. Okay.
What peristaltic delivered?
Okay,
system?
right,
Okay.
right. After that, every other week, we add a powder product just to act like a booster.
Okay.
Okay?
Sure.
To bring back the biomass that we need to have on the system. So we combine both products in order to benefit our client and to assure that we're gonna get the right effluent. Okay?
Okay. And this is like a monthly service that you conduct?
Yeah,
or
this is a monthly
monthly
service. Yeah.
Okay, so it's once a month the technician
Once a
goes
month,
in there.
and we work 24 hours a day if we have to do it.
So some of the accounts actually get called on Sunday, Saturday?
Yes, because most of these accounts work 24 hours a day.
Right.
They have a lot of volume, you know.
Okay, okay. As far as, we had also talked earlier about the grease trap itself, and I know here in the United States, we do have a lot of the municipalities that actually test the effluent, you know, as it's coming out of the grease trap and actually going into the city. And I was just curious, do you guys do testing similar to that, or are you familiar with that?
Yeah, you just mentioned one important thing, because in Puerto Rico, we are a small island. We are only 100 by 35,
Oh, wow.
okay? So the waste disposal cost is very expensive, okay? So in order to assure that we get the right effluent, we provide to our customers every 3 months quality test on the effluent. We measure the pH, the oil and grease, TSS, to make sure that we are complying with the parameters established by the water authorities in Puerto Rico.
That is great. That's a major plus, because I know here in the United States, we don't have any companies that I'm familiar with that actually goes that extra mile to do the testing. I guess in closing, what do you feel makes you and your company successful in this business?
Well, service is the most important part of this of our success. Service, you have to have a great control of your people, of your team.
Right.
We are a big family. Okay, we treat our customers as a part of our company, because this is like a joint venture. Okay, we
Right.
have to work together in order to get the results that we expect.
And I think one of the things that you told me earlier was that you guys actually use a written report
Yeah,
too when
yeah.
you go in, which is a service
Yeah.
report that I think it kind of backs up everything that you're doing in there. It's kind of a reinforcement, and also, I guess, it protects you and your company at the same time, to show that you're actually completing all the services that you are supposed to be providing.
Yeah, we keep files since we installed our systems. That way, let's say one of the government agencies wants to know what happened with the grease trap a couple of months ago. We go and check on our files, and we have a complete log of the parameters, the procedures of our service. So we keep a good file on every account we serve.
Great. Eric, thank you so much
Thank you.
for spending some time with us. We wish you much success in your company, and again, thank you for meeting with us today.
Thank you.
Thank you.
many of which are toxic. The balance of nature is under threat. Yet these advances in technology are creating new developments which will help restore some of the traditional balances of nature. Biotechnology is enabling us to develop environmentally safe solutions to meet these problems. The International Biochemicals Group, founded in 1976 and now a wholly owned subsidiary of the Royal Dutch Shell Group, is one of the leading commercial organizations in the field of applied biotechnology. Through our innovative approach, we have developed a successful range of high-quality biological products that utilize the power of natural microorganisms. Interbio's approach is based on a thorough understanding of the role of the microorganism in nature. In the natural cycle of life, microorganisms perform many tasks. One of the most important is the ability to break down waste and dead matter into the basic elements essential to the regeneration of life. Over the years, our research and development team have isolated and developed hundreds of superior strains of microorganisms. These now form the blueprint for all our products. To illustrate how a strain of microorganism comes to be part of a product, let us take a simplified example. A customer wanted a safe and easy method of keeping drain lines free of grease in a situation where detergents were being used. The problem facing our R&D team was to develop a product which could degrade grease whilst being able to withstand a certain level of detergents, as well as other factors, such as wide temperature variations. The R&D team started by taking a sample of grease from a drain which contained suitable naturally occurring microorganisms. In our Dublin laboratories, this sample was worked on for over 3 years until a single strain of microorganism was derived. This process, which we refer to as accelerated evolution, is where the fastest growing microorganisms are continuously selected, whilst being subjected to increasingly heavier concentrations of, in this case, detergents. The end result was a range of super microorganisms, which degraded grease and grew at a much faster rate than organisms found in the natural environment. Only when this microorganism was fully identified and approved by an independently recognized laboratory was it included in our culture bank. Each of our products consists of a specific selection of microorganisms which, when blended together, will perform a certain task. For example, cleaning up an oil spill, improving degradation in wastewater treatment plants, or preventing drains clogging with waste. The success of our product formulations lies in the significant synergy we achieve from this blending of different strains of microorganism. The high product quality Interbio offers our customers is possible because of the methods and technology we employ in the production process. The production plant is one of the most advanced facilities for the production of microorganisms in the world. This enables us to put in our final product a unique selection of superior microorganisms at an extremely high count per gram. The manufacturing process begins with the selection of a single strain of microorganism from the culture bank. It is important to note that although hundreds of different strains are stored in the culture bank, only a single strain is manufactured at a time. Before the batch is taken beyond this stage, the strain is verified as having the correct characteristics. Then, at each stage in the production process, the batch is rigidly quality checked for purity. Unique to Interbio is our ability to use 2 fermentation techniques in the production process: deep tank fermentation and solid substrate fermentation. Through this, we are able to put into our products a complex selection of microorganisms whilst maintaining very high counts. Using state-of-the-art technology, these fermenters are fundamental to our manufacturing success. Highly sophisticated in their custom design and computer control, the fermenters give absolute precision over growing conditions for the microorganisms. Their performance is an important factor which enables InterBio to achieve the exceptionally high ratio of microorganisms per gram in our finished product. In the deep tank fermentation path, the cultures are grown up in the fermenters. The microorganisms are then treated with chiroprotectants. Coating the microorganisms extends the shelf life. A carrier material is added and the microorganisms are then freeze-dried. The solid substrate fermentation path provides an additional growing stage. The microorganisms are mixed with a bran carrier and placed in incubators. The tropical conditions provide an ideal growth climate and will produce a very high yield of microorganisms in a relatively short time. After drying, the single-strain batches are temporarily stored until the finished product is ready to be blended. At this point, the product is mixed in accordance with a predetermined formulation of microorganisms. A final comprehensive quality check occurs at the packing stage to ensure that the finished product meets its full specification. InterBio's prowess is in the development and manufacture of a range of products made from microorganisms. With our strong commitment to research and development and the additional resources of Shell's extensive research facilities at Sittingbourne, we are well placed to continue to lead the market in the exciting sphere of applied biotechnology. Success, however, doesn't end at the factory. InterBio is committed to a complete service, from the development of a range of high-performance products to providing comprehensive support for our customers. Hence, we put a lot of emphasis on having a technical backup team who spend their time in the field assessing and advising on the application of our products. InterBio's sales and marketing professionals are based in London and Chicago. With the backup team, they are continuously feeding back information from the end user to the research and development facilities in Dublin. This essential link with the end user has given us the success we now have and will ensure that we continue to lead the market with a sophisticated range of safe, high-performance products. InterBio are using tomorrow's technology to provide safe products for the protection of our environment today.
Institutional, aka Jansan, aka consumer, aka money. Different markets. Cruise line sanitary systems, liquid and dry. Example, cruise ships. Treat each cabin. Some of them have 1,200 cabins. Give an example of an application. They'll use about 1 liter of liquid product to keep their drain lines clear. Odors, they use 1 liter per cabin per month. One cruise ship. That's 1,200 liters of product once a month. That's just for the cabins. That doesn't go for the galley, the kitchen, or the holding tank, the septic. Hotel sanitary systems, same deal. It's on land. You get all the, here. Grease traps, septic tanks, shipboard holding tanks, drains, beverage towers. You guys know what a beverage tower is? It's that little tray underneath that fountain drink thing. What application is that? Well, all that sugar and fructose goes down that. It just builds up and bacteria cling onto it. You clog it up, it overflows, and starts to stink. Keep it clean. Start with the dry products. EBR D30. What does EBR stand for? Enzyme Bacterial Research. We just
Baton Rouge.
We should buy them.
no, they
Just came up with that.
at same plant. They just changed the name for institutional products. D30. The D stands for dry. 30 is just formulation name. This is a dry powdered product. Minimum spec of 2 billion per gram. 2 years. This produces those 4 basic enzymes. For fats, grease, cellulose, proteins, starches. This product is bugs only. No nutrients, no surfactant added. Used for grease traps and septic systems.
Quick question right now. Would you
Yeah.
say the institutional products are basically like little brothers or little sisters to all the industrial
brothers.
products because
That's
they're
right.
just concentration?
Correct.
Now, why, you mentioned about it doesn't have any surfactants. Why is the surfactants important?
Good question. Next product. EBR D30F is EBR D30, but is formulated. Formulated meaning has surfactant, has nutrients. Well, which one's better? All right. Why do we have the same product, but one with surfactant and one without? Remember those municipal codes that say you can't use surfactants and this, that, and the other? Well, okay, don't. Use D30. Bugs will work. If you can use a surfactant, it is a benefit because surfactants serve as a wetting agent. It makes water wetter. Well, it emulsifies oil and grease. You got a chunk of grease. The bacteria have to chew on it, emulsify it, and then take care of it. If you can emulsify it and spread it out, more bacteria can degrade it. Increase surface area. It's got nutrients in it too. Septic tanks, drain lines, stuff like that. I sell more EBR D30F than I do D30. People want more for their money.
And usage amounts.
Do what?
And dosages.
Dosage rate, good question. Typically, we'll use 1/8 of a pound maintenance per day. Why do we dose per day? Because people taking the mop buckets full of a gallon of bleach or Comet or something and dumping it down in the grease trap. Kill you bugs. Hot water. You're required by law, restaurants are, to use what? A certain amount of chlorine in their wash water. Where does that go? Down the drain line. Into the grease traps. Kill you bugs. Repopulate. Yes?
You said 1/8 of a pound per what per day?
Oh, I didn't finish, huh? 1/8 of a pound per 1,000-gallon grease trap per day. Sorry about that.
If it's smaller than 1,000 gallons, do an 1/8 of a pound.
Yeah, up to 1/8. I mean, up to 1,000. Standard grease trap is 1,000 gallons. If you got a big one, obviously we increase that. For every 1,000 gallons, you will go to 1/4 of a pound, to 1/2 a pound. Now, these are the dries. I'll tell you about the system that a lot of people use. here after I talk about the liquids. What do these do? They don't go in and clean out a grease trap full of grease. No, no. The return on investment, Frank's going to talk about here in a little while, is it prevents the frequency of pumping while eliminating odors, reducing odors. What is a nightmare for a restaurant to have? It's customers coming in and smelling that grease trap.
Back up.
Been there.
But then they put the
Been there,
on all
didn't
that
eat there.
stuff. Then they
Been there, left there.
Yeah.
Do you know of any products that actually do and claim that they do and do eliminate pumping? Will totally control. the
Totally
grease?
eliminate pumping?
Yeah.
If they plug off the grease trap and don't send anything through it, I mean, no, you're going to get solids that bacteria, nothing can handle.
So, yeah.
Totally eliminate? Yeah, enzymes and surfactants. Eliminate it out of the grease trap, but not eliminate it down the line to the TOTW or the ditch or wherever it goes.
And the one thing that's nice is when they do get a clog up, the only way to clear it is chemically first,
Correct.
and then they've got to restart.
Yeah, this is not an opener. Bacteria are not an opener. They are a maintenance, a preventive maintenance. And I don't want to, I'm not going to go into ROI. I won't let Frank toot that horn. But best thing to do, have that grease trap pumped out first, cleaned out, right out them lines, start the program. Say they're pumping it out 2 or 3 times a month. I've got clients that they ain't pumped in 2 years. I've got some typically, if they pump 12 times a year, I could get them down to 3 times a year. You had a question, Jose?
No, it's just we also distribute oil water separators, which we could use these bacteria to go along with the package.
Most definitely.
Oil water
A
separators.
beautiful synergy with that.
They're gaining a lot of popularity in our girls.
Correct. But the key is, you know, they want to use the bugs. They don't want to pump as much. Why do you have to clean it out first? Because the bacteria create a biofilm on the inside of the pipes. Inside the pipes, inside the trap, on the baffles, on the biofarm, which we'll drag out here in a little while.
Wait a minute.
Take care of the oncoming grease. Yes?
When you set this up for a maintenance dosage of a 8 per pound per day per thousand,
Yes.
when you set it up on a pump or something like that, you do tend to get some kinds of odors or something like that if you have it sitting there for a few days.
The dry, yes. If you do it with the dry, why is that? Because of the bran.
Any way to overcome
And it's
it?
not aerated, the bacteria are starting to degrade the bran. That's what we get our liquids for. That's what we use the liquids for, in the spore form. They will not activate until they hit that grease trap.
How much more cost efficient is this than just having a pump? I mean, besides the odor control, how much money are you talking about saving somebody?
Frank bought it.
That's
An
right.
eighth of a pound.
An eighth of a pound?
A day.
Let's put it this way.
What is a pound?
Typically, it depends on where you are in the United States. A grease trap pump could cost you $100 a pump.
Yeah.
Or it could cost you $800 a pump. You know, there are some places where it's $800 a pump because they can't get rid of it.
That's right. That's right.
Hazardous waste.
If they're pumping it out once a week, typically, you know, we say, you know, it's a fourth of the cost of pumping. Because what do? You reduce the pumping 4 times at least. And then if you use the system right, and you got it going good, they may not pump in 6 months, a year. All right, liquid products. Note the L in the middle, EBR L30. This is not D30, but in a liquid. It does the same thing. These are our liquid spore bacteria, 4 strains. We sell them in concentrate. 4 times to 6 times concentrate. Why do we sell them in concentrate? Because nobody wanted to buy them and ready to use anymore because they pay them for shipping of water. No, we can't offer it in ready to use. EBR L30, If you get it with color and fragrance, it is a white color with like an aerolescence perfume type deal. Smells pretty good. Without color and fragrance, it really has not a whole lot of odor, but it looks like muddy water, just kind of turbid, chock full of bacteria. It has surfactant in it also, yes.
Well, Raymond, I was thinking, is there such a chart that shows what are the specific dosing amounts per application on a charted form, on a tabulated form?
Not on a chart, but each technical data sheet on the products on the back for institutional has a dosage recommendation, not really a chart.
Most of the products have dosage on the back, with the exception of those where the sensitivity is such that it could be very broad, and those are going to be case by case. Just no way of wanting to tell you a dose and then have it be the wrong one. But you'll.
Is this the type of product that you sell to consumers?
This one, no. No, this is for grease traps and septic. The next ones I'm getting into are certainly ones that we would do that for. This is one with surfactant. Why do you need surfactant again? What's it used for? Emulsify. More surface area. Keep it moving, keep it clean. Okay? 6 times concentrated is as concentrated as we can get it. Why? Because when you dilute it down, you still want to have a good bit of surfactant. So if it's a 6 times concentrate, you got a good bit of surfactant in there. If you increase that even more, then the surfactant becomes so concentrated it kills the bugs. Yes?
In that one project that I was talking to you about where we were looking at the 10X,
yes.
If we went with that, with the best thing to do, you probably have some type of surfactant added on the side.
Certainly.
If you wanted to go where they're basically double dosing. But I don't know, that's...
or you can pre-mix it whenever you...
have you ever run into that before?
Oh, yeah. I have distributors that do that now. EBRL30 is a good product. It's very successful. Well, let me talk to you about that system. Pretty much because you ensure that you don't have to go in there every day or every week to an account and service it and dose the product yourself. You have to rely on the human factor. How do you get out of that? A metered pump that will dose it in automatically. Reduces the risk of failure. Go on a liquid program for the grease trap and drain lines, dose it, and it works fine. What's even better? Yes, odor control and preventive frequency of pumping. What's even better is dosing the product and then having them spike it once a week with the dry, directly to the trap. Just spike it. Or use this and use that biofarm with the biofarm insert inside. Retain your population on all that surface area and degrade the grease. Okay, L40 also, you were asking about consumer products. This is a reformulation product. A lot of people say, hey, I make my own surfactant. Mine's the best. I just want the bugs. This is bugs in water. And because they're in spore form, they can take it to their drums of surfactant. Say they got, 55-gallon drum filled up with about 40 gallons of surfactant and water and whatever their secret brew is. Put my bugs in, just as long as there's not nutrients and food in there. Put my bugs in there, and you got their, for a formulated product. A lot of people do that. What's the maximum amount of surfactant that you can package these bugs with? Don't go over 15%. I like to keep it 10 or under. But 15% or more, it starts to get a bit inhibitory.
Non-ionic, anionic.
A non-ionic surfactant.
Any preference with phenols or linear alcohols or
Ethoxylated. What we use a 9 mole, and then there's a 15 mole. And
Hot water application.
do what?
Why the 15 mole for hot water application?
Well, kind of getting out of my
That's about
realm there.
Over 90 degrees
Yeah, there's a
centigrade.
heavier density type deal. It's more emulsive. Depends on whether you want a hard surface cleaner or whether you just want a grease emulsifier. You know, getting into moldage, I'm not too hip on it.
15 mole last time, when it's done, it looks
Is
like
it thinner or thicker?
the
15 moles thick.
We generally have to cut 15 mole with 9 mole to be able to run it through our pumps.
Okay. Makes sense. All right. L40. We do sell this in a 10X. Because there's no surfactant. We can get that. Actually, yeah, 4 times and 10 times. We stopped doing the 4 times and 6 times because nobody bought it. Everybody likes the 10 time concentrate. We're not shipping water. You can reformulate it. Save a lot of money and make a lot of money. All right. RBC M14. Shipboard holding tanks. It's a dry product, similar to the EBR D30F, but it's 3 billion per gram. It's got a time-release oxygen source, some surfactant, and nutrients. Can you use this in bilges? Kind of, sort of. If you got a lot of gasoline and battery acid and stuff down in there, I wouldn't advise you using 109. But what does this do? Time-release oxygen source cuts the odor. It's not anaerobic. CHT lines. Transfer lines.
So it's a CHG line.
Cleaning, holding, and transfer. Rbc Septic. This is EBR D30 renamed. Why is it renamed? Because Rbc Septic is packaged in quarter-pound polyvinyl acetate bags. This is where we sell it in the 25-pound pails, 120 of them in a pail. So it's really 22.5 pounds. This is for people that sell to the septic industry. One of these little 4-ounce PVAs will, for a maintenance dosage for a 1,000-gallon septic tank, and it's on the back of the data sheet. 1, throw it into the toilet, let it sit there for 30 seconds or so, and then flush. 1 treatment per month for a 1,000-gallon tank. This is dosage thing. What do you do during a startup? Triple that dosage. In other words, in a month, I typically say, throw one of these bags in once a week for a month. What does this do? Opens up leach fields eventually, or keeps them from becoming plugged. Degrades paper. Odor control. Keeps lines open. All of our dry products are packaged in half-pound and 1-pound. We call them backpacks. The backpacks are 50 cents per pound upcharge. The only product that we package in the quarter-pound is the Rbc Septic. I do have the capability of packaging the products in that PVA, but with minimum quantities. In other words, justify the work.
What would be the largest bulk package you would ship something in for repackagers?
Something about the size of the Exxon Valdez tanker.
Oh, so in other words, I mean,
No. The biggest one I've ever loaded up was
like in the dry compound, I would say.
dry. One of those big, what do you call it, a roll-off? 40 by 20?
Oh, okay. And they put it in there with nothing like insulation?
100-pound drums.
Oh, okay, in 100-pound drums. Okay.
Yeah.
So repackagers basically would take it in 100-pound drums to
Certainly.
repackage. Okay.
Standard package is 25-pound pails, 50-pound and 100-pound drums. Liquid, 5-gallon pail, 55-gallon drum, 275 tote bin, 60,000-gallon tanker truck. Oh, and 1-gallon containers also, but it's not standard packaging. We have that available. We need minimum quantities. Yes.
Do you have this in liquid?
The septic? Yes.
Are the dosage rates the same?
Dosage rates for the septic is going to be 10 ounces per month.
In the 1,000-gallon, that's a typical?
1,000-gallon standard dosage, standard size.
And when he was talking about the cleaners, that brings up a point. Would you say that perhaps you ought to recommend to a household user, if they are using bleach-based cleaners to clean the toilet, to turn around and dose it after they clean it? Or does that make sense?
Yes. And same thing we do in the restaurants. Whenever they want to implement the bioaugmentation program or a maintenance dosage, do it after you've cleaned up. And then run water, flush water through it. Dilute that bleach. Maybe they dump hot grease down that grease trap.
The GoPro plants are almost all chlorine based.
Yeah, I know.
Yeah, but, and I think Dennis can attribute to this, is the chlorine based. The residuals are gone after you dilute it for so long. That's why you flush it with the water and then come in behind it.
Yeah.
But when you stack it on top, you add the bugs and then the chlorine on top. You just shoot yourself in the foot. Good question. Rule of thumb, free chlorine, 2 ppm kills all microbes in vegetative state. Some spores can handle 20, 25. So I'm sure there's some that can handle more than that.
I think the standard for disinfection is like 1 ppm for 30 minutes for food plants. So it depends on the time as well, right?
Well, there's a time factor, yeah.
But when you go down a drain, I mean, it's almost instantaneous.
Correct. And I was going to get to that for filaments because it typically determines how much you would chlorinate your return activated sludge line going to the treatment system too. 2 ppm kills. 1 slugs. Make them real sluggish.
Going back to the EVR, you said you can mix it 10 times. What kind of mixing procedures? Or is it just water? Any preservative?
The L40? Whenever you dilute it down, any preservative, we have a stabilizing preservative in there. When you mix this, I would also, don't worry about tap water. That's actually better. Tap water has chlorine in it or some fluoride in it. It serves as an inhibitor and allows increased shelf life. You inhibit the spores from wanting to come out and become vegetative. So you can add just about anything that is non-toxic to the spores to the L40, but it cannot be a food source. If it is a food source, they will acclimate and they'll come out. And just to give you an example of what will happen, say for instance you got a 55-gallon drum and you stuck in some nutrients in there and you stuck it in your warehouse and it gets nice and warm. You ever seen a can that's got botulism in it? Those things will explode. When they explode, they got this foul stench, really pungent odor. And I've had gallon jugs and containers where they've taken their own brew, surfactant and nutrients and put in a couple of the dry bugs in it, left them on the shelf for a couple of weeks, exploded the bottles. So as long as there's not a food source mixed with this, you still get shelf life that you can know. Surfactant can be a food source. If you put it in light concentrations, it could be a food source. That's why you don't go too high, but you don't go too low. The range would be, don't go over 15%, but you start going below 1%, and that's a trace. But also you got to imagine that there's no oxygen in there too, or there's very little oxygen. So food is what drives them to come out, but the pH needs to be right. Dilution, air, temperature.
Brandon, in large application products like for parks and recs,
yes,
do the oxygenators or oxidizers help in odor reduction?
Oxygenators?
Well, the oxidizers, do they help in odor reduction?
Certainly. What you're doing is you're changing the environmental parameters to, you're changing it from an anaerobic to an aerobic.
So because you can't ensure good mixing, how do you know that the product works beneficially?
If you can't assure good mixing,
right. The only mixing you've got is
turbulent.
Raymond?
Yes.
Some of our products have slow release oxygen sources, but what about, we talked yesterday about adding oxygen in the form of, say, peroxides or, say, nitrates or other things that are, which would provide oxygen sources. What are the limits of adding those kind of oxygen sources typically?
It depends on what the compound is. For instance, like
as far as
calcium
our bugs, yeah, like sodium nitrate would be a common one.
Typically what I do, same thing for nutrients. I try and keep it the same as a line. If you were going to add nutrients or a time release oxygen source or something, for every 25 pounds of bugs, it requires 1 pound of fertilizer or 1 pound of time release oxygen. 25 to 1 ratio. Think about it that way, because if you take 25, remember that CMP ratio, 100 to 5 to 1? Take 25, multiply it by 4, you got 100. Okay? And then take that 1 pound, multiply it by 4, and you got 4. So in that 4, it's usually DAP. It's like 50% ammonia and 12% phosphate, something like that. Depends on what the chemical makeup is. But rule of thumb, for every 25 pounds of dry, 1 pound of nutrient or 1 pound of oxygen. Just to give you a rough estimate. Hydrogen peroxide, ppm, over 250 will start to inhibit microbial activity. 250 ppm. That has no correlation with DO though. You may have a DO of 1 with 200 ppm of hydrogen peroxide.
You see that a lot? That's a high concentration.
No, I don't see it.
Okay.
I don't see it. And a lot of people will use that for like hydrogen sulfide control, sewer lines, and they'll dose the hell out of it. Or some people that can't aerate because of remote areas with no electricity or something say, hey, I'm going to start this thing up, so I'm going to add a couple of drums of H2O to it. How much can I use? What is my limit? Don't go over 250 ppm, you kill your bugs. What you'll inhibit, I would say 300 or more, you start to kill them off.
And that's being used in a lot of bleach plants too, instead of bleach.
Yeah. So, Randy, that's something like what you're talking about, like the hydrogen peroxide, calcium peroxide. Like you were saying earlier, that's fine. But with the chlorine, or maybe the bromide, whatever they're using, that'll kill the hell out of bugs. That does have an effect. That has an effect. So I think what they're doing is, they're helping the bugs that may, first of all, is, hey, we have the hydrogen peroxide, which is friendly. Let's not talk about this chlorine. We have this. We kind of have this. promote one thing, have the other. Okay. All right. Reformulation of the liquid 40. Any questions on that one? Get shelf life as long as you don't add food to it. And get shelf life just as long as you don't add it to a secret brew that'll kill it. Okay, now let's talk about consumer products. By the way, these are products that were formulated, most of them in the ready-to-use form, that we sell to distributors, or want to sell to distributors, that they can private label, repackage, and put on the store shelves. Let's talk about it. Consumer products include carpet cleaning, hard surface cleaning, septic systems, drain lines, algae, spot remover and odor control. Similar products. Drain opener, boat bilges, compost. Big G.
I was gonna say, that's a big G.
Stressing the compost bean. Okay. All right. EBR L50, and the CF stands for color and fragrance. This is the drain maintenance. Yes. Liquefies and dissolves drain clogs with bacteria capable of breaking down typical household waste. Bacteria leave a biofilm that helps prevent buildup. It's a preventive maintenance. This is better than the liquid plumber drain maintenance thing. We've got laboratory testing, comparative analysis. Actually, we did for you guys of this versus. Matter of fact, about 4 of them. I can't remember all the names. We did some for like Riddex, for septic and stuff. But ours really showed up, and we did comparative analysis against it. This is not an opener. It's a drain maintenance. That biofilm, just like grease traps. But this is sold in ready-to-use form. The benefit here is, this is where I really wish Terry Owens was here. He's the consumer guru for distributors. I'm just a tech guy. But where you really can make your money is we sell it to you in the drums, and then you have your own contracts or whatever for bottling, labeling, and stuff. So it becomes very cost effective. Okay.
When y'all compared it to the liquid plumber, did you compare it to the older alkali version or to the new bacterial version?
The new bacteria. Oh yeah.
Yeah, what's apples to apples?
What can you attribute the benefits of the product over the liquid plumber product?
Benefits?
Yeah, why is it better?
Number one, higher bacterial count. But the importance of it is when they do something like that, remember there's 4 enzymes, basic ones? The plumber one has 2. The cellulase and the lipase. We do an enzymatic activity test. Our products, those 4 strains of microbes, which we have, they have 2. No, they have 3. We produce all 4, positive for all 4 enzymatic activity, which means they break down that way so they can then degrade it.
They have cellulase, lipase, and
Amylase, protease.
I mean, the liquid plumber, which one didn't it have?
I can't be 100% certain. I know they had the lipase, which is very important for grease, and then I think it was either cellulase or protease. Yeah. This is an example of our biofarm. Basically, I explain it to people who are affiliated with fishing. There's a cricket box with a bunch of netted ping pong balls.
Good explanation.
What it is basically a packed bed reactor, trickle filter, It's got a lot of surface area. Yeah, just pass it around. And what he has there is the Biofarm insert. It's a paraffinic plug, a VBR D30, that is time release, stuck down on the inside of the bio reactor there, the Biofarm. And over 20 to 30 days, it sloughs off into the Biofarm.
Now, would this be good for lift stations?
Certainly.
Right.
This was invented for grease traps. I do have distributors that use that in lift stations. Extremely successful.
What is it below, like, there's a lot of fine granules, you shake it?
That creates weight because we want this underneath the grease cap submerged in the water. That's sand or something, gravel or something, pea gravel.
How does the lift station plays up? They're taking the big horse garbage out of the
Okay, a lift station. Define a lift station is, we're in New Orleans. Biggest lift stations in the world are here. Pumping station.
Okay.
Basically, there's a gravity. In other words, municipalities are generally around here. Louisiana's flat. We have a few. It's basically where you have so much flow and then it's got to go uphill, okay, to get somewhere, or you got so much volume. A lift station is a retention basin that basically, when it fills up, it has an automatic meter pump. Pump kicks on and it lifts the water up, pushes it. And you'll hear them sometimes if you've got one in a neighborhood or something, you'll hear it kick on. And you hear the rushing of the water go through. It's pumping the water up to a higher level. Gravity, instead of gravity. A lot of places that have drain lines that run downhill, they don't need lift stations. They may have wet wells, which are basically tiny little EQ basins or retention, by where they hold the water. When they fill up, they trickle on down into a weir.
But it's not associated with sewage treatment, it's just the water level management?
No, it is sewage treatment. It's
So
sewer main.
it's water level, it's basically in a flat area. The sewers go down and they go low, 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 and then you gotta start again somewhere in the process, whether it be treatment or something,
You want to have a constant movement of water.
These are accumulation areas too. They fill up with grease constantly.
Yeah, it's a good point. They go to the sewer plant.
You just
And they
raise
pump
flow
in the
levels
water
to increase your
constantly.
detention.
Because it's a retention, you get high grease, and because you hold it there a while, and if it doesn't pump, you get no turbulence, which means aeration, and you get odors. And the neighborhoods call the mayor and say, hey, it stinks out here, do something, blah, blah, blah.
This is like pre-treatment then for it would almost be
Certainly.
cheaper.
This is an application where we take the backpacks with the immune back, Biofarm, stick it in there because they have to go in there all the time and jet that out. And they get plugged, and I'm looking for the word here. What happens whenever the grease plugs up the pump? What do they call that?
Cavitation.
Cavitation. Yeah, and that's expensive. Have to go and replace those pumps. EBR L60. Hard surface cleaner. Bacterial count 50 billion per gallon. A lower count. But what is the purpose here? This contains high amount of surfactant. Surfactant lifts the oil and grease, the stain, gets it solubilized wherever you wash this down to, in the grass, in the sewer. The bugs have been there to take care of the surfactant and the contaminant. And there are many, many, many people out there that'll have their magic poo-poo snake, and they'll go out there and clean up that big old spot on your carport or driveway or parking lot and say, yeah, look at them bugs work. Bugs do not, will not, cannot, never not. Yes?
What's a good product for cleaning oil off your driveway?
This.
That's what you're saying? I'm sorry.
That's it.
Paying attention.
That's it, right there. But it's not the bugs. It's not really the bugs that are doing that. Surfactant is getting it up. It's a cleaner. Now, how could you get bugs to do that? Well, take the oil spot, build you a little levee around it, fill it up with water, add your bugs,
Some driveway.
go over there with a straw and blow air through it every once in a while, and in a week, it'll be gone. But then, that's right, adjust pH temperature. And I'm sure it's been tried.
Lower the pH
For the boomerang.
I've had people back a long time when I first started this company, they would take a dry brand material, throw it down there, just leave it there and come back, like an absorbent. And it left a bigger stain than they had in the first place. Because the bugs, you know, they sprayed it with water, hey, they're working and everything. But the bugs, that glycocalyx, that slime layer, when it dries up in the sun, it turns black. They have a bigger stain. You know, so. The EBRL-60, hard surface cleaner, the surfactants emulsify the oil and grease, get it up, and then the bacteria then take care of it.
Yeah. The restaurant floors, the kitchen floors and stuff, not recommended or
Yeah.
cost effective compared to what they're using now?
Actually, I have people using the L30 to do floors with too. Mop bucket water.
You mentioned here that it can be used for countertops. So this, if you meant a countertop.
Non-food handling countertops.
Okay.
Non-food handling countertops.
What about food handling countertops?
No bacteria. No. USDA will nail your tail.
He doesn't have the USDA to worry about.
That's true.
They
still would advise you.
Actually, even FDA will not allow products with bacterial content to be used in food preparation.
Correct.
Regardless whether it's a
Nobody. EPA, OSHA, God, everybody. No.
Then where do you apply those?
The hard surface cleaner, oil on cement. Machinery, tool, people clean, all right, parts washers.
Those are hydrocarbon normally.
Correct. This is hard hydrocarbon or any type of, it could be fog.
Animal fats.
Oh, that's easy to degrade.
Vegetable fats.
Now, petroleum hydrocarbon in a liquid. It is limited on its petroleum. It will take it a long time to degrade it. Okay? How we came about with this? Gas station parking lots. They were using acids to clean that off. It goes down the sewer and gives the POTWs hell. A lot of people that approve products to be used said, okay, send us a sample of what you're implementing or you want to use, and we'll see if it works. What they did was, they took it, okay, the surfactant emulsifies the oil and grease, yeah, but then what happens? The POTW gets it, okay? Well, we have bacteria in here that'll eat it. Okay, we want to make sure. Shake flask study, did the test, ate the surfactant and the oil and grease. Okay, yeah, you can use that. Knowing that the bugs are not eating it right there, they're eating it in the drain line all the way to the municipality. And if they reach a municipality, they only can help, then hinder.
But you're hurting your business that way. You missed your big bug sales when that POTW just...
I know.
It's good.
That's why we don't sell a whole lot of this.
How would you apply this? Would you spray it on and let it sit and then wash it off down the drain?
No, what you do, applying, wet the surface, spray this on, pour it on, scrub, then spray off.
And what time frame?
What time frame?
Yeah, 10 minutes, 15, let it sit.
Yeah, minutes, not an hour or so.
And then it's going to go down the drain just like emulsified oil and water,
Yes.
milky looking.
The bacteria will be activated by the end and they start giving it up. Dilute it. This is in ready to use form. Have somebody who has bought this before and cut it in half. It works. Also, the next one I'm going to go over is ready to use, and I know somebody who's cutting it in half and it works fine too.
On that,
though I try not to advocate that.
On the bioinsect.
Sell less by.
There's deodorized toilet bowl surfaces.
start off with the products. I want to do this for each of the products that we have, basically to show you what we have, what kind of power that product has, what kind of organics they degrade, industries used in, and opportunities. And then we're going to go into some troubleshooting, like what type of industries have what problems, what questions do you ask. If I go too fast, please stop me. A lot of the products kind of overlap, and I'll kind of speed on through and say, hey, 103 is like 109, this, that, and the other. So take good notes, but all of this is basically on the technical data sheets as well as the menus. All right, let's do it. What I want to do is I want to start off with industrial products first. I like to start off with these because these are the most technical. And once we go through these, the other ones will just fly through and it'll all make sense to you. All right, industrial wastewater products. Basically, the industries and the markets we sell into. Petrochemical, refining, meat packing, pulp and paper, chemical, poultry, food processing, food and vegetable processing. Each of these industries don't have a single product. A lot of the products overlap with the problem, and we'll go through that. Continuation, wood treating, marine, livestock, and this is all in the data sheets and stuff. We'll go through it. I'd rather go through the products. Okay. I'm also going to rate these as the most common and the most sold for InterBio. What sort of industries that they use? Start off with Rbc 103. Just to talk to you about the names, Rbc stands for Reliant Biochemical. It's a company we bought in the early 80s. It's our Houston facility. We acquired that plant and converted it to InterBio. We just kept the formulation names the same because I sell to distributors who also private label. And why change it into a name that maybe a distributor has already had? I don't want to take the air out of your balloon. So we keep the same names. It doesn't really mean anything. One question that does come up a lot, though, is they say RBC. A lot of people, especially for international, they'll think it's red blood cell. Something like I've been called so many times from a customs official saying, hey, what are you sending red blood cells across the border for? This, that, and the other. You have to have this permitted. All right, Rbc 103. This product is mostly used, and what I'll do is I come up with keywords for each product. Complex organic hydrocarbons. I call it organic soup. It's a blend of 11 strains of microorganisms with the synergy of producing enzymes to break down phenols, sulfur compounds, organic sulfur compounds, sour crude. Sour crude. Definition of sour crude is oil that contains greater than 3% sulfur in it. Okay. You'll see resorcinol, methacrylates, chlorinated hydrocarbons, amines. Very important here. At the bottom you see BTEX amines. This is very important because when we get into purposes of nitrification, you'll find out that our nitrifiers generally are the last part of the stage. We like to nip it in the bud. A lot of times amines will be the problems, and we'll go into that later. This is the product that we'll use a lot of times in conjunction with nitrification. What happens is when you take these, whenever you break down something, it all wants to become soluble as close to you can sugars. So even chlorinated hydrocarbons will be broken down eventually into simple sugars. There's a lot of steps in that process. Anybody's familiar with the Krebs cycle, the glycolysis cycle? There's many, many steps, many different enzymes used to break that down. Different bacteria produce different enzymes. These enzymes work with each other. One bacteria degrade phenol down into another type of, maybe an alcohol as a byproduct, and another bacteria will degrade that as their carbon source. So they work in synergy. That's why we have blends of bacteria to do such. Okay? This product is used in the chemical industry, petrochemical, meat packing because of the sulfur compounds. You use a lot of sulfites, high CODs. Okay? Miscellaneous solvents, alcohols, 103. We sell literally tons of 103. It's a very popular product. It's very strong. I've even got some accounts that use this. I have another product that I like to use in food processing because of the heavy fats, oils, and greases. But I have a lot of clients that use this, but fats, oils, and greases of a vegetable or animal nature are very easily degraded. When I talk about oil and grease, I'm talking petroleum oil and grease. If you have petroleum oil and grease, this product can handle certain amounts, but a high amount of oil and grease, I have a better product that has a combination of these both. Okay. Keyword again, Rbc 103, complex hydrocarbons, organic soup. Pretty much, if you've got a wastewater treatment system, industrial, you want to treat this, it's either going to be 103 or 109. And my question is, do you have heavy oil and grease there? If it's a yes, it's 109. If it's a no, it's 103. And if I really don't know what it is, I say, send me a sample. Okay? Rbc 104. Keyword for this, pulp and paper. This is a blend similar to the Rbc 103, but it has 2 additional strains in it that are superior cellulose degraders. Obviously, because paper is cellulose. Biggest problems in paper mills is lignins, which are your lignins are the wood glues, high sulfur. That's why you pass by a paper mill, it stinks. It always stinks. Key here, you're not going to treat a paper mill because it stinks. I smell money. You don't smell it because you're going to go in there for odor control. That's a facultative lagoon. Basically, they take the lignins, they degrade it down into a stable end product called sulfate. Sulfate in the aeration basin then goes to the facultative lagoon. Facultative lagoon means what? It's not aerated. These bugs that are there are going to use what as an oxygen source?
Sulfate.
Sulfate. And you liberate H2S gas, and that's what you smell, especially in a sulfite mill. Okay. Rbc 104, the lignins. This is also called black liquor. You've heard the term, I've had a black liquor spill. When this hits the system, it's very, very, very high COD. Kills the bugs. You know, remember that forcing a cow down your throat theory? That's what occurs here. You have your green liquors, white liquors. These are different bleaches they use, looking for what kind of craft paper, maybe parched paper, stationary type stuff. Sometimes they'll have paraffinic, waxes, corrugated container material. Okay. Rbc 104, we sell tons of this. Why? Because paper mill, in the process of making paper, it uses tons and tons and tons of water. This is a paper mill aeration lagoon here on the wall. Lots and lots of water. They have lots and lots of space because they cut lots and lots of trees. All right? So, heavy TSS BOD. Lots of aeration. They spend tons of money on aeration and bugs every year. I also note that this is a very competitive industry to sell into, the paper mills, because they tend to marry the clients, the vendors that treat them. These vendors are in those mills weekly, taking care of it, because they're dosing 25 to 50 pounds a day. Maintenance dosage. When they have an emergency, 2,000 up to 7,000 pounds in less than a week. That's some bugs there. All right. RBC 104. Where else can we use this? Remember the applications we were discussing? Well, yeah, you could, but it would be kind of expensive to use the industrial product and septic tanks. But yes, you have a lot of paper and cellulose there. I've got another product that has these, and we'll get to that. Vegetable processing, wineries. Why? What's that? What is that? Sulfate. What? You have that.
Well, a lot of cellulose.
Cellulose, the rind, the stem, the seeds, sludge. Another problem, TSS. Paper fibers emulate filamentous. They're very filamentous-like. They float, hard to settle. That's why cellulose is hard to degrade. Cellulose breaks down into starch. Starch is a complex sugar. So it takes a lot of retention time and a lot of bugs to treat that. Well, first of all, how do you get a longer treatment time in a system? You have to settle it. It's hard to settle paper. So you dose a lot of bugs to get that flock and settle it to the bottom.
Raymond?
Yes.
In the Rbc 103, are there strains in that would also be common to 104? Of those 11 strains?
I want to say exact, but I won't say exact. I want to say 95% the same. The percentages of the cultures of each species may be a little off, but the bugs are the same.
The reason why my question is because we have done some work in wineries.
Yes.
Using the 103. It's worked extremely well.
103, when I say 104 for cellulose, it has 2 additional strains that is pretty much the only enzyme that they produce, specific for. But 103 has bacteria in it. Remember those 4 categories, cellulase, lipase, protease, amylase? They produce all 4 of those. And you will get cellulose reduction with it. But I mean, if this cellulose in papers, what you're looking for, are 104 specific. But to answer your question, 104 is basically 103 with the cellulose bugs. Spike. Okay? RBC 105, by the way, these industrial products are all dry with a minimum shelf life, guaranteed shelf life of 2 years with a minimum count under ISO at 3 billion per gram. This does not mean they leave the plant at 3 billion per gram. They leave the plant at 4 to 5, sometimes 6. Depends on the product that we have. Okay? So we guarantee that if you test it after 2 years, you'll have a minimum spec of 3 billion per gram, bacteria per gram. These are dry on that brand carrier I was discussing.
Well, on that subject, touch a little bit on we're getting requests from some regulatory agencies to specify what's in the product in terms of pathogens and all kinds of things like
Correct.
that. How do you proceed with that?
2 ways. We have the capability, and note the word capability, of testing all products against pathogens, salmonella, E. coli, fecal coliform. We have the capability of doing so. In our industrial products that are not used in food handling areas, they're not required. I want to say OSHA doesn't require, but I won't. That you have to have pathogen-free in industrial waste treatment or municipal, because it's pretty much there anyway. But if you use this in a food processing plant, you may be required to have a certificate of analysis saying that it is salmonella-free or pathogen-free. If you want the product tested, your lot tested salmonella-free, let me know. Not a problem. No extra cost. It will take a week lead time tacked on. RBC 105. These are our nitrifiers. And it's no secret, this is a nitrous ammonium. Everybody knows that the nitrifiers are this nitrous ammonium. It converts ammonium to nitrite. Nitrous ammonium does not take nitrite to nitrate. Sheer aeration alone will do it. Okay? much more detail on this in a little while. Now, a key word here. Note that RBC 105 does not degrade ammonia. It oxidizes it. You cannot degrade an inorganic. RBC 106, oh, by the way, we do sell lots of 105 also. But mostly on an emergency type situation.
To what industry?
Good point. Mostly the refinery. And I'll go into this in more detail when I get to troubleshooting, but basically, refineries are treating crude oils. Crude oil contains a lot of sulfur. There's a compound, amine, which they use to desulfurize crude for sulfur recovery. Amine is NH2. One more hydrogen, you have ammonia. So if you have free amines in there, they're looking for another bond. And if they don't bind with the sulfur, they become ammonia. So what you want to do is prior to that, say you have a amine problem, add RBC 103 or 109. Or 104, you could use 104. For the most part, 103 or 109. Nip the amines in the bud because they take care of it. They prevent the ammonia from becoming a problem. Then you add the 105 to take care of the ammonia that hadn't been formed before. Okay? Refining. Chemical, they actually produce ammonia. And a lot of the chemical industries are pretty much the only ones that will use it on a maintenance dosage. Because nitrifiers take up about 3 to 7% of the bacterial population of wastewater system, activated sludge. Okay? Food processing plants. Why is that? Food processing like poultry. Meat. What's meat made of? Protein. What's protein made of? Which are made of what? Amines. That's right. Okay. Another analogy. This is my dead dog theory.
We'll get the cow and the dog.
The dead dog theory. You're on your way to work on a hot summer day. Dog runs across the interstate. Pow, you hit him. Okay? Dog's made of meat. Alright? Knock him over into the median there. You come back and you did kill him. He is dead. You come back 6, 7 o'clock or whatever time you get off. You see that same dog laying in there. In a day's period of time, he's all swole up. What's going on here? Decaying. But what happened? That's right, gases. Anaerobic degradation. Now, let me get to my point. And listen to the words. Most bacteria can degrade proteins. I should say break down proteins. Break down proteins. Most bacteria can break down proteins. Some bacteria can break down amino acids. Few bacteria can break down amines. Many proteins, some amino acids, few amines. What do you have going on here? Within a day, you got all these bacteria indigenous in the dog's gut, on the ground, on his skin, now degrading the protein. And it's a rapid occurrence. But then let that dog sit there for a couple of days. All of a sudden he'll get to that point, almost of like diminishing returns, where now it's starting to take a little longer. Because the protein's gone, now you got that, and it stinks to high heaven. Gases, acids, amino acids. Then you have amines, you pass by, you got that decayed flesh. Remember that? Pass by, amines are fleshy, and then you have diamines. These are two amine molecules with an organic hooking it together. This is a decayed flesh smell. Now the degradation is starting to take longer because some bacteria do that. And then when you're down to about the skin and the bone, you have your amines. and this could take a long time. Okay, I digress. RBC 106. This is a specialty product. We sell it, but we don't sell a whole lot of it. This is a blend of about 6 bacteria, specific for foams, surfactants, detergents, soaps, ethoxylated hydrocarbons, some light phenols, Narcardia foam. Narcardia foam is AKA surfactant. It will not go and degrade filamentous, but it does degrade the filamentous surfactant. So what I'm saying here is not use 106 for filamentous control, though you can use 106 to aid in the reduction of the foaming and odor control for it, while you're increasing wasting rates or return activated sludge chlorination. Okay? And we will go into more detail on that application. Okay. RBC, okay, when we use 106? In an application where COD, BOD is just fine, you know, all your waste is being degraded, but then you got that pesky foam that maybe you got a high surfactant loading from industry upstream. And everything else is okay, but you just need to treat that detergent. Now, key word, how much detergent? Less than 2,000 ppm. You get above 2,000 ppm, you break the surface tension and they're not able to utilize oxygen. Less than 2,000 ppm. And you look at the COD whenever you want to measure that. How do you measure surfactant? If you know that's what your problem is, look at your COD. If it's 2,000 or below, we can generally do something with it. Now, can our other products take care of surfactants? Certainly. But not as highly specified as 106 can. This is a special product. Okay? RBC 107. Well, the key word for 106 is soap, detergent, surfactant. All right. RBC 107. Grease. Oil. This is a specific product. We sell slightly more of it than we sell of 106. You would think we'd sell more, but you'll find out next why. RBC 107, specific for high oil and grease of the petroleum hydrocarbon nature or fats, oils, and greases. Naphthalenes, polynuclear aromatics. This is used for odor control. A lot of refineries use this if they just have an oil and grease problem. Food processing plants that have a facultative lagoon that have a 5 to 3 foot thick layer of grease on the top, acts like a cap for an anaerobic digester almost, but they have sludge on the bottom and have water in the middle section. They do not want you, most of the time when you go in there and say, geez, you got a 5 foot thick layer of grease on the top, it's nothing but a big old grease pit. Yeah, but you poke a hole in that grease cap and I'm going to sue you. Okay? They want that cap there. They don't necessarily want it very big. They want it just thick enough to hold that gas in, which has got to be pretty thick. And also meet their effluent discharge permit. Okay? 107 will do it. Produces enough surfactant to keep the bottom moist and soluble and keep sloughing off as it's building on. You kind of keep it in maintenance, but treat the water. Soluble grease. Use this product if everything else is in line. BOD, COD is okay. Everything else is fine, but I just got a pesky sheen on my water that I want to take care of. It's the only problem I have. Okay, we've got a specific product that'll do that. RBC 108. It's a cold weather. Remember psychrophilic, refrigerator degrading bugs? This is that blend that we can blend with our industrial products and municipal products, cold weather applications. These microbes produce a thick, viscous slime layer that jackets the water around it. Acts like a coat, protective sheet. One that's not listed is Rbc HT. This is a thermophilic blend, high temperature. We rarely ever sell that. Matter of fact, I haven't sold a single pound of it. Because generally they don't worry about high temperatures. Not generally a problem. They'll let the bugs acclimate to that. Cold weather, certainly we sell this. You can order it in 108 if you feel like you got a client that has a lot of it in stock. It's got a lot of 103, a lot of 109, a lot of 104, something like that. And they're dosing it, but they know it's cold weather. So they'll order a couple of drums of the 108 and add it in.
How cold?
Do not get below 40 degrees Fahrenheit. Below that, you can add this, you can add anything, it ain't gonna work. Yeah, just sit there and go, it's too cold. Typically we do an 80-20 blend. 80% the product, industrial product, 20% cold weather. And when whenever you order like 103 plus, 109 plus, that's what we do. Take 80% of that product, put 20% 108 with it.
Would you do the same for the HT product?
Certainly. If need be. We sell a lot of this in the wintertime. Summertime, we don't sell nothing. No 108. Rbc 109. My favorite. This is the most sold product in our biohouse. Why? Well, look at all what it degrades. Why does it degrade that much? It's a damn good product. All right, what this is a combination of Rbc 103 and 107. So it can do everything that 103 can and everything that 107 can. And because you synergize those two blends, you also encompass other things like styrenes, ethylene glycol, antifreeze, heavy oil and grease. That's why I say you got an organic soup, and my first question is, do you have an oil and grease problem? Yes, 109. No, 103. Will 109 work in 103 circumstances? Yeah. But 109 has 13 strains, 103 has 11. We don't take all 8 strains of 107 and add them to 11 strains of 103 and get 19 strains of bacteria. No. Some of the bacteria are the same. So, if you have a specific application where you have complex organic soup but not oil and grease, don't use the 109. You could, but you're better off using the 103 because you have more of those strains geared towards that waste.
Cost-wise, are they similar?
Yes. Roughly similar. Close enough, few cents per pound. Okay, run through it quick. Oh, one of the most important, PCP, pentachlorophenol, creosote, asphaltics. That synergy between the 103 and the 107 gives you those tar. That stuff's hard to degrade. 109 is also used in soil too. Soil bioremediation. Trouble with that word. Creosote constituents, chlorinated hydrocarbons. Just about everyone who's talked to me has heard 109 come out of my mouth. It's a good product.
Is this the Valdez bill?
Yeah. 109, it was used under the name Super C back then.
Super what?
Super C, C-E-E. Don't ask me why that name was used, but that's what they called it. 103 was used, let's run down. The National Contingency Plan products.